Hey guys, today we're going to be finally talking about slope-intercept form. Okay, and this is the form that you will use for the rest of this unit and the rest of the year. You'll always want your equations to end up looking like this. Okay, so the slope-intercept form, the equation that you're going to be using, is always going to be y equals mx plus b. Okay, and your m is always going to represent your slope, and your b is always going to represent your y-intercept. Okay, you must memorize these two things. Okay, so again, the slope is always going to be the coefficient of x, or the number in front of x. Okay, and your b is always the number that's added and subtracted. Okay, and a point to note. Okay, this only works, and I would write this down, this only works if y is solved for. Okay, you must have solved for y to be able to use this formula and to identify slope and y-intercept. Okay, so please remember that. Okay, so we're going to go ahead and look at a few sentences, and we're going to write an equation that results from that sentence. Okay, so if we read this, it says write the equation of a line with a slope of 6 and a y-intercept of 84. Okay, we know that we want to use y equals mx plus b. Okay, and remember, m is our slope, b is our y-intercept. Okay, so we simply want to plug these different values in up here for slope and y-intercept into our equation. Okay, so we're going to plug that in there where we have y equals, and remember our slope is 6, so we have 6x, and then our y-intercept is 84, so we're then going to put a positive 84 in there. Okay, so that would then be our equation of that line. Okay, let's try another one real quick. Okay, this time it says write the equation of a line with a slope of 17 and a y-intercept of negative 33. Okay, so we're again going to plug in our slope of m and our y-intercept of b. So we would have y equals 17x minus 33. Okay, so whatever number you have for your y-intercept, you're plugging that number in there. Okay? All right. Okay, so let's go ahead and graph this function real quick. Okay, so the first question, it says, is the equation in slope-intercept form? Well, if we look at this equation, it sure looks like it's in the general form y equals mx plus b. So yes, it is in that form. Okay, and we want to identify the slope and the y-intercept. Okay, the y-intercept, of course, is your b part. Okay, so we're going to bring down our negative 3 for y-intercept. And our slope is always the number in front of x. So our slope, or m, would be 4. Okay. So if you wanted to go ahead and graph this, there's two different ways. One, you could do a t-table, which I'll show you first. Okay, so if you had your t-table, x, y, and you have your 0, 1, and 2 values, you would say 4 times 0 is 0, and subtract 3 and you'd get negative 3. And then plug in 1, 4 times 1 is 4. Subtract 3 and you get 1. And if you plug in 2, 4 times 2 is 8, subtract 3, you get 5. Okay, so you'll notice if we go ahead and plot this, we have 0, negative 3. We have 1, 1. And we have 2, 1, 2, 3, 4, 5. Okay, so if we go ahead and draw that line, it should look, well, it's a terrible line. Okay, if we draw that line, it should look something like this. Okay, but another way you can know how to do it is if you know the y-intercept, you can go ahead and plot that point. Okay, so our y-intercept is -3, so I'm going to put an intercept on the y at -3. Okay, then we can go ahead and use our slope. Remember, slope is rise over run. So if we do a 4 over 1, that's the same as a slope of 4. Okay, so let's apply that slope to that y-intercept and see what happens. Okay, so if we go up from that y-intercept up 1, 2, 3, 4, and to the right 1, and then go ahead and draw our line, well, looky there. Okay, you end up having the same exact line without doing the t-table. Okay, so that's something that we will continue to practice a little bit. All right. Okay, so let's go ahead and try another one. This time is our equation in slope-intercept form. Well, it's in y equals mx plus b form, so we are in good shape. Okay, so this is yes, it is indeed in slope-intercept form. Okay, and let's identify the slope and the y-intercept. Okay, our slope is always m, and our slope is the coefficient in front of x. So we have a -3/2 slope, or a rise over run of down 3 over 2. And our y-intercept, or b, is our number after that, or a +4. Okay? Well, remember, I told you that you want to graph your y-intercept first and apply slope second. Okay, so let's try this. Well, we have a y-intercept of 4, so we know that intercept is going to be located on that y-axis. Okay, so we want to go ahead and put that point right at 4, which would be right here, +4. Okay, and we have a rise over run of -3 over 2. So from that point, we want to go ahead and go down 3 and over 2 and put our point there. Okay, so we're applying our slope from that y-intercept, and then we can go ahead and draw our line. Okay, so now that you know this little trick, graphing lines can then become very, very easy. So let's try a couple more here. All right, so we want to go ahead and graph these following functions here. We're going to try a couple of examples. The first one is y equals -5x plus 8. And the first thing we want to do is go ahead and identify what your slope, or m, is. And remember, your slope's always the coefficient in front of x. So we know in this case that it's -5. And when you have a slope, you need to have a rise over run. Okay, and then your change in your y direction over your change in the x direction. So you can put a 1 underneath your -5, just so that you can visualize what that rise over run is. Okay, and then you need to find your y-intercept, okay, or your b. Your y-intercept is always the number after your slope and your variable. Okay, so in this case, we have a +8. So we'll just have our y-intercept of 8. Okay, so now that you have those two pieces of information, you can then go to the graph and graph it. And remember, you want to start with your y-intercept first, and which that is 8. So we're going to go up 8 spots on our graph and plot our y-intercept. Okay, so plot your point right there. Okay, next, you want to apply your slope to that point. So from our y-intercept, I then want to apply my slope, which is down 5 over 1. So from that point, I'm going to go down 1, 2, 3, 4, 5, and to the right, 1 spot. Okay, so now that you have your 2 points, you can then, of course, go ahead and draw your line through those 2 points. Okay, and that gives you the graph that you would want. Okay, so with this last example, I would like you and a partner to go ahead and try to find the slope, the y-intercept, and then go ahead and plot those two pieces of information on the graph. All right, we have a couple of examples left, and we need to figure out how to find the slope and the y-intercept given two ordered pairs. Okay, so you know that you can find the slope using your y2 minus y1 formula. So if you plug in this into that formula, it would look like -4 minus 5. Remember, those are y1 and y2. And you want to put that over 0 minus 3. Okay, so if you looked at that, -4 minus 5 would give you -9. And 0 minus 3 would give you -3. Now if you go ahead and reduce that, our negatives cancel out, and 9 divided by 3 gives us 3. Okay, so our slope in this one would be 3. And then we want to look for our y-intercept. And we've talked about before, what is the x value of y-intercepts? Well, we know that it's 0, and you'll see that our ordered pair right here does in fact have an x value that is 0. Okay, so since we know that that is a y-intercept. So our y-intercept on this one would be -4. So we can go ahead and then graph our information based on that. Since our y-intercept is -4, we can come down here at -4 and plot a point. And since our slope is 3, we know our rise over run would be 3 over 1. So I'm going to go up 3 and over 1 from that point to get my next point. So up 3, over 1, and then draw my line in. Okay, so that is how you do it given two ordered pairs. Our last type is to find slope and a y-intercept from a table. And remember, from yesterday, we talked about to find slope from a table, you need to do the change in y over the change in x. Okay, so if you look at this table, what's happening every time to get from one y to the next? Well, it looks like you are adding 2 each time. Okay, so we can go ahead and plug that in our formula, and then we just have to figure out what the change in x is, and well, that's easy. Every time it's just adding 1. Okay, so if we take 2 divided by 1, that will give us a slope of 2. Okay, well, how do we figure out the rest of the formula? We know the slope is 2, but how do we get the y-intercept? Well, if we figured out the pattern, we could go ahead and figure out what that y-intercept is. So since we know that you have to multiply x by 2 and then do something else, we can figure out what the y is. So let's take 3, our first number in our t-table here. Let's multiply it by 2. So that would give us 6, right? Well, how do you take 6 and get it to -6? Okay. Well, of course, you're going to have to subtract 12. Okay? So if we wanted to get our pattern, we know that we have to multiply x by 2, and we have to subtract 12. Well, guess what? That looks like my slope-intercept form, and we can see that my y-intercept is -12. Okay, and then, of course, you could go ahead and graph that right here. And what I want you to do by yourself is to graph that and show it to me. See ya.